Hi everyone. Today we're going to look at one of the harder concepts to explain in science. Today we're going to look at viscosity, what it is, and how we apply it. Viscosity, put simply, is the thickness of a fluid. If we look at it qualitatively, a more viscous fluid would appear to take longer to flow, as it can hold its shape before forming the shape of the container. When we say normally honey is thicker than water, we could also say honey is more viscous than water. So now that you know what viscosity is, we'll cover what affects viscosity and how we can apply this to the common fluids that you and I know. So the first thing I want to talk about is how we can relate our previous knowledge of particle theory to viscosity. Let's take a cup of oil, for example. We learned that from the first video that oil is actually made of tiny particles, and since oil is a liquid, these oil particles are moving, not just vibrating. We also know that there are forces of attraction between these particles. When we pour this liquid into another container, that liquid tries to fill the new space, and as a result, these oil particles must overpower those attractions to move into the new container. Therefore, it's how strong these attractions are that determine a substance's viscosity. Now, how can we change a fluid's viscosity? If we go back to particle theory, we recall that thermal energy increases the speed of the particles. Now, if we heat a fluid up, this increase in energy and speed would allow the particles to overcome the forces between them, which would give the appearance of some very viscous liquids like honey to flow like water. A really simple way to try this is to stir some honey and then make a good guess of how much effort you need. Try it again, but this time put the honey in the microwave. You'll see how much of a difference that makes. Alright, now that we know what viscosity is, let's look at some of the crazier aspects of this property. Now, let's say here we're in a room where the temperature does not change. If we have a fluid in this room and its viscosity doesn't change, then we can call this fluid Newtonian, named after Isaac Newton, or the physicist who discovered viscosity. Now, most fluids are Newtonian, such as water or oil. However, there are fluids that defy this law, and then we call them non-Newtonian. Let's give an example. Why does ketchup not spread out after it's squeezed? It behaves like a liquid when we're pouring it, yet it behaves like a solid when it's on food. On the other side, we have another mixture of cornstarch and water. When it's not moving, it behaves like a liquid. If we apply a force, like punching it, for example, it acts as a solid. Both liquids are non-Newtonian fluids and are able to change their viscosity based on whether a force is applied to it. In ketchup's case, the viscosity decreases when we apply a force, like trying to pour it out. In the cornstarch and water case, viscosity increases when we apply a force. Alright, so that's a quick introduction to what viscosity is. So, now I have two questions to see if you understand what it is. First, if we have ketchup, honey, and water on a slanted board, which would slide down first? Explain using viscosity. Second, we have a cup of oil. How could we change its viscosity? Alright, thanks for watching. Make sure you try the cornstarch and water experiment sometime at home.